Find an equation of the line tangent to the curve at the point corresponding to the given value of the parameter. Here our curve is given by x equals e to the square root of t, y equals t minus the natural log of t squared, and t is equal to 1. Well, we need to find the tangent line, an equation of the tangent line, at the point corresponding to the given value of the parameter. So the first thing that we might do is try to find that point corresponding to the given value of the parameter, which in this case is t equals 1. So finding that point just boils down to substituting substituting the value of t into our equations for x and y. So if t is equal to 1, we have x is equal to e to the square root of 1, which is just e, and y is equal to 1 minus the natural log of 1 squared. 1 squared is 1. The natural log of 1 is 0, so y is equal to 1. So our point here is e comma 1. This is the point at which the line is tangent to this given curve. Finding an equation of a line, you really need, well, it depends on which version of the line, which form of the equation you use, but if we use the point slope form, then we need a point, which we just found, and the slope. The slope of this line can be found using the derivative because this is a tangent line. So the slope of the line is going to be the derivative of y with respect to x, and it's going to be when t is equal to 1. Remember that if we're given a set of parametric equations, we can find the derivative of y with respect to x by finding the derivative of y with respect to t and dividing by the derivative of x with respect to t. And then again, we're going to evaluate this when t is equal to 1. Well, here, x is equal to e to the square root of t. So the derivative of x with respect to t is e to the square root of t times, the chain rule kicks in, the derivative of the square root of t, which is going to be 1/2 t to the negative 1/2. So we could rewrite this as e to the square root of t divided by 2 square roots of t. Remember that a negative exponent drops that factor into the denominator, and the 1/2 power is the same as the square root. So there's our derivative of x with respect to t. Now the derivative of y with respect to t. Y is equal to t minus the natural log of t squared that's given in the problem. So the derivative of y with respect to t is equal to 1 minus the derivative of the natural log of something is 1 over that something, but then we must multiply by the derivative of the inside. Again, the chain rule. The derivative of t squared is 2t. Here, one of these t's will cancel, and so we end up with our derivative of y with respect to t being 1 minus 2 over t. So, we have found dy dt, and we have found dx dt. So we can divide those, and that's our derivative. So dy dt is 1 minus 2 over t, divided by dx dt, remember we found as e square root of t, divided by 2 square root of t. And we want to evaluate this when t is equal to 1. Well, we could either do the simplification first, or we could go ahead and put in our value for t. So in this case, let's go ahead and put in t equals 1. So 1 minus 2 divided by 1 over e to the square root of 1 divided by 2 times the square root of 1. 2 divided by 1 is equal to 2. 1 minus 2 is equal to negative 1. Square root of 1 is 1. e to the 1 is just e. 2 times the square root of 1 is just 2. So finally, we flip and multiply, or multiply by the reciprocal, we get negative 2 divided by e for our slope. So now we have the slope of the line. We have a point on the line. Point slope form says that y minus y1 equals m times x minus x1, where x1 and y1 is a point on the line, and m is the slope of the line. Remember, we found a point on the line at the beginning. We found out the point E1 is on the line. So y minus 1 is equal to, and we just found out the slope is negative 2 over e, x minus x1, and we found out that was e. So an equation to of the line tangent to the curve at the point corresponding to the given value of the parameter is y minus 1 equals negative 2 over e, x minus e.